do just that. Or I might start you off and ask you to finish it. Or I might just not do that. I might just finish it altogether. All right, so let's turn the page. Remember what f of z is? Cube square 3 plus 5. So this is saying f of z is equal to z cube minus z square plus 3z plus 5. Am I correct, guys? Hello?
Yes. Yes, sir.
I'm correct. And what we want to find out is if z is equal to 1 plus I, 2i is a root. Now, according to factor theorem, if I substitute, if I did this, find f of 1 plus 2i, which means anywhere in the function wherever I see z, I take out z and put 1 plus 2i. If that works out to be, and when I work it out, I'm gonna get 0 for the entire thing, it means therefore that what? 1 plus 2i would be a root, and z minus 1 plus 2i would be a factor. That's what it's saying. So I'm gonna do exactly that. This is 1 plus 2i cube minus 1 plus 2i square plus 3 times 1 plus 2i plus 5. When I work this out, according to the factor theorem, which you can all see before you, if f of 1 plus 2i comes out to be 0, z is equal to 1 plus 2i is a root, and z minus 1 plus 2i would be a factor. All right, so let's work this out. This would be 1 plus 2i square multiplied by 1 plus 2i. That's the cube, minus, let's square 1 plus 2i. So this is 1 plus 4i plus 4i square. All I did was just square what? 1 plus 2i. Plus 3 into 1 plus 2i, and you have got to be patient, plus 5. And what we are trying to do is to see if this is going to work out to be 0. We just squared 1 plus 2i, so this is 1 minus 4 plus 4i. Any objections? Multiplied by 1 plus 2i. Any objection to the first part?
No, sir.
All right, I'm going to remove the brackets here. This is minus. All right, let's not remove the brackets yet. So this is 1 minus 4 plus 4i. Huh?
Is it not 4i squared?
No, it wouldn't be 4i squared. What I did is, remember, in the I square is going to be equal to minus 1. You remember?
Yes, sir.
So if I square is minus 1, 4 times minus 1 would give me minus 4. So that is why I have 1 minus 4 plus 4i. Are you good?
Yes, sir.
All right. Then now, plus over here, 3 1s 3, distributive law. 3 2s 6, I plus 5. I'm working down. Over here, I'm not jumping anything. So this is minus 3 plus 4i multiplied by 1 plus 2i. And this is just still what? 1 plus 2i cube minus 3 plus 4i plus 3 plus 6i plus 5. Let's do the binomial to the left. This is minus 3 minus 6i. plus 4i plus 8i squared. Distributive law, negative times a negative is a positive 3. Negative times a positive is a negative 4i. Plus 3 again, plus 6i, plus 5. All right, so this becomes minus 3. Minus 8. Minus 2i plus 3i, 3 minus 4i plus 3 plus 6i plus 5. So we're simplifying, let's get all the numbers together. This is minus 11 plus 3 plus 3 plus 5. For anybody looking, I'm quite sure you'll see that that is 0. Then we have minus 2i minus 4i plus 6i. Can you all see that the entire thing is going to work out to be 0? Can you see it?
Yes, sir.
Yes, sir.
So this is equal to 0. Now you see if f of 1 plus 2i comes out to be 0, that means therefore z is equal to 1 plus 2i. Let's not take up so much space. Therefore, z is equal to 1 plus 2i is a root. By showing that f of 1 plus 2i is equal to 0, what we're showing is that z is equal to 1 plus 2i is a root, and that z minus 1 plus 2i would be a factor. All right, the question is not finished. We're also asked to solve the equation f of z is equal to 0. We're asked to solve the equation f of z is equal to 0. Here, I know what the man did, and based on what he did, I'm going to do the same thing. I had some questions about it, and when I'm finished, I'll get a chance to see if you had similar questions. Now, normally, if you have a cubic polynomial to solve, what you would do is, after you get one linear factor, you would then divide the cubic polynomial by the linear factor. And when you do that, you would end up with a quadratic factor. And then all you'd have to do is factorize the quadratic factor. But here, we're going to approach it a little differently. What the person who wrote the book did is he used the fact that because all the coefficients are real, it means that the roots must occur in what? Conjugate pair. So if z is equal to 1, the roots must occur in conjugate pair. So if z plus 2i is a root, it means that z is equal to 1 plus 2i is a root. It means that z is equal to 1 minus 2i would also be a root. You understand what I was saying, guys? Guys, are you with me?
Yes, sir.
Let's repeat the statement again.
All right, here's what he said. Initially, when we started this, we said that if all the coefficients are real, these are the coefficients. The coefficient of z cubed, of z squared, of z. If all the coefficients are real, it means therefore that the roots must occur in conjugate pairs. So what that means is that if z is equal to 1 plus 2i is a root, it means therefore, z is equal to 1 minus 2i must also be a root. Because once the coefficients are real, the roots must occur in conjugate pairs. Now, if those are roots, it means that z minus 1 plus 2i and z minus 1 minus 2i, that these are factors. So these are factors, I can multiply them. Let's multiply them to get the quadratic factor. So if I multiply this, z by z gives me z squared, and z times that gives me minus 1 minus 2i z. Multiply this gives me minus 1 plus 2i z, and then the next one gives me a negative times a negative is a positive 1 plus 2i multiplied by 1 minus 2i. All right, let's just work it down to get our quadratic. So now this is z squared. All right, let's apply distributive law. Minus 1 plus, sorry, this should be minus z. All right, no, let's just make z the common factor. Minus z. Inside the bracket, we're going to have 1 minus 2i plus 1 plus 2i. Over to the right, this is the difference of 2 squared. It's going to be 1 minus 4i squared. This is going to be z squared minus z. Inside the bracket, I have what? This goes, so that gives me 2. Over here, I have plus 1 minus 4. So what I would end up with is z squared minus 2z plus 5. That would be my quadratic factor. Now, we're going to factorize completely. If I multiply that by some other factor, z squared minus 2z plus 5, multiply by az plus b,
Excuse me, sir.
go ahead.
Sir, before you continue,
Go ahead.
what were we working? I understand what you're working out, however, I lose track for.
What we're working on now is we need to solve the equation f of z is equal to 0. That's what we need to solve.
No, sir, I'm talking about the part that you said z minus 1 plus 2i in bracket, and then you have z minus 1, 1 minus 2i.
What I'm doing is I'm multiplying the two factors so I can get the quadratic, so that I can get the quadratic factor. Okay. I'm multiplying the two linear factors so I can get the quadratic factor.
Sir, so you were saying that if 1 plus 2i is a factor, the conjugate is also a factor?
Yes, 1 minus 2i would also be a factor, because if the coefficients are real, the roots occur in conjugate pairs.
Okay, sir. So you can continue now. Thank you.
No problem. What we need to do now is to find out what is A and what is B. This is Z cube. Sorry. Minus Z squared plus 3Z plus 5. Minus 3Z plus, sorry, minus Z squared first. Z squared plus 3Z plus 5. Our objective is to find out what A and what B is. Everybody can think of the simplest way to do that?
Sir, you went low for a minute. Can you
Yeah, man,
repeat
I
the
said,
question?
can anybody think of the simplest way to solve the rest of this? The simplest way to find out what A and what B is.
Sir, multiply.
Let's multiply. This time this will give me what? A Z cube. I'm multiplying this by that. That's what I just did. So now I'm going to go this by that. So this is minus 2AZ squared. And times that gives me what? 5AZ. Then I'm going to multiply by B. This is what? BZ squared minus 2BZ, and then plus what? 5B. I'm simplifying the left side first. Now I have AZ cube. Let's get the Z squares together. Minus 2AZ squared plus BZ squared plus.
Excuse me, sir.
Sir,
can you please excuse me for a few minutes?
All right.
Right.
Please ensure that you watch the video of this.
Okay, sir.
All right, hurry up and come back. Guys, let's continue. All right, so now we have what? 5AZ minus 2BZ. And then lastly, we have what? 5B. And this now is equal to Z cube minus Z squared plus 3Z plus 5. All right. What I'm going to do now is that I'm going to equate coefficients. If these two polynomials are equal, whatever is in front of A cube on the left whatever is in front of Z cube on the left must be equal to whatever is in front of Z cube on the right. It means therefore that that A is equal to 1. And I'm going to put in bracket Z cube coefficient. So answer this. What is Z cube coefficient on the left? Anybody? Guys?
A.
What is Z cube coefficient on the right?
1.
1. So it means that A is equal to 1. What is the constant term on the left? What is the constant term on the left? The constant term is the term that has no Z in it. What is the constant term on the left?
Sir, 2 on the left?
Yes.
5, sir.
It's not 5 on the left. It's not 5, not 5 alone.
5B.
5. It means that 5B would be equal to, what is the constant term on the right?
5.
5. And I'm going to put here constants. All right, then if I divide both sides by 5, I'm going to get b is equal to 1. Let me see if I had the good sense to create space around here so to finish this thing. No, I didn't. All right, guys, stay with me. I know it's tedious. But we've got to stay with it until the very end. All right, so what we have now is that this is the same as saying z squared minus z squared. Sorry, let's not use z squared. We just got the third factor, z minus 1 plus 2i multiply by z minus 1 minus 2i. Those are two of the roots. Now multiply by what? Z is 1 and what? B is 1. So this is this factor now, z plus 1, and this now is equal to 0. It means therefore that z is equal to 1 plus 2i, z is equal to 1 minus 2i, and z is equal to minus 1. Those are the roots of the, those are the solutions of the equation. Any objection?
No, sir.
Those are the roots of the equation. Look at it. Do you consider it painful? Let me stop the video.